In this video, we'll look at a few more examples of translations, how they work on the coordinate plane with transparency and the rule of movement for every point, same direction, same number of units. So if I have two triangles, that was a transformation called translation done because my triangle, original triangle, let's say if this one was triangle that I started with, pre-image, I can translate it to the left and then up. So if I take this triangle and go 1, 2, 3, 4, 5, 6, 7, 8 units to the left, and then let's say 1, 2, 3, 4, 5 units up, then it ends up in the same corresponding angles and sides place. It means same orientation. So in translations, we need to slide the figure the same number of units for every vertex, the same direction, and we follow the instructions given by the problem. In the example number 5, I have to translate the figure 4 units up. So what I'm going to do is use the rule and then check with my transparency. So I have a triangle ABC. ABC goes up 1, 2, 3, 4. Every vertex will go up 4 units. 1, 2, 3, 4. C, 1, 2, 3, 4. And when you connect the new vertices, the image is exact same size because the pre-image has to be congruent to the image, and it has the same orientation. So the triangle has the same orientation. To check that, we can use our transparency, A, B, C, and follow the rule. Translate means move or slide 4 units up. So check one of the vertices, or which one you look at doesn't matter, but you have to make sure that it goes straight up. So let's say I focus on B and I go straight up. 1, 2, 3, 4. And all of them follow in the same direction. So all the vertices go the same way, same number of units.
Please come to the front of the school.
If I have to
To the front
translate,
of the school. Thank you.
Translate means slide or move the figure 3 units to the left. It means that every vertex, A and B and C and D, goes 3 units to the left. So A, 1, 2, 3, and label it A prime. B, 1, 2, 3, label it B prime. C, 1, 2, 3, and label it C prime. D, 1, 2, 3, and label it D prime. So the vertices A, B prime, A prime, B prime, B prime with C prime, A with D, and C with D, connected, showing the quadrilateral moved 3 units to the left. That motion can be observed by moving a transparency A, B, C, D. Some of you may use the transparency first because that gives you a good visual of where you should end up. So if you have your pre-image and transfer it on the transparency and go 1, 2, 3, then you have a good idea where you need to end up. So sometimes when you transfer one vertex at a time, and if you don't label them, then you start mixing up what goes where. So what helps at first until you get better is to use the transparency and physically move the figure so you know what the final result should be, and the figures have to be congruent to each other. In example number 7, I have the vertices given by coordinates, and I can use my organization chart here to do additions and subtractions without the coordinate plane to show the translation. So in the direction it says the vertices of triangle ABC are, so I'm going to record here, A is 2, 1, B is 3, 4, and then C is 1, 3. So without the coordinate plane, I can use this X and Y to do my additions or subtractions based on the movement. Find the coordinates of the vertices of resulting image A prime, B prime, C prime, and D prime if the translation was 1 unit down. Down means along the y-axis. So every time we move up or down, we're moving along the y-axis. So 1 unit down means I have to subtract 1 unit from the y-coordinate. 1 unit down, again, down is along the y-axis, so 1 unit down means subtract or go down 1 unit from y. So all my y-coordinates I have to subtract by 1 unit down. And 3 units to the left. So 3 units to the left. Every time we move along the x-coordinates or x-axis, that is right for addition, left for subtraction. So 3 units to the left means you have to subtract 3 units or 3 from the x-coordinate. So moving to the left is subtraction, and subtraction along x-axis means subtract 3 from x-coordinate. So from the given coordinates, we can calculate the points that we end up based on the movement up or down, which is addition or subtraction from the y-coordinates, or left and right, which is addition and subtraction from the x-coordinates. So you just need to be careful what is the movement and what you're adding or subtracting. Then 2 minus 3, if you subtract 3 from the x-coordinate, we need to end up at negative 1, 0, 1 minus 1. For b prime, we need to end up at 3 minus 3 is 0, 4 minus 1 is 3. And for c prime, we need to end up at 1 minus 3 is negative 2, and 3 minus 1 is 2. So this is based on calculations. Then we're going to do it on the graph so we can see if we ended up in the right location. So A is 2, 1, and we label it right away. B is 3, 4, and C is 1, 3. That's a little tiny triangle right here, A, B, C. This is my pre-image, and then the image will be the movement following the rule. So what I'm going to do is use my transparency to help myself see where I should end up. And I need to go 1 unit down, 1, and then 3 units to the left. 1, 2, 3. Okay, and that's where I'm going to end up. Or I can move 1 vertex at a time. So B goes 1, 2, 3 to the left, 1 down, or 1 down, 3 to the left. A, 1 down, 3 to the left. And C, 1 down, 3 to the left. 1 down, 3 to the left. And you can check the corresponding vertices are in the location where we actually had our transparency. And those exact ordered pairs we'll check after we connect the vertices if we have the same based on calculations. So here's point A in -1, 0, A prime. And here's B prime in 0, 3. That works. And here's C prime in -2, 2. -2, 2. That works. So we did our calculations first, then we proved it that it is the same exact on the coordinate plane. Questions such as identifying if the transformation made was a translation. So does the image below represent a translation? Let's explain and see what happened here. Based on the definition, after the translation, the pre-image and image have to be exact same size and exact same orientation. So this is what we had as a attention point in the previous page. After the translation, the image will be congruent to the original pre-image and have to be the same exact orientation. So congruent and same exact orientation. These two triangles appear to be the same orientation, but they're not congruent. So if I look at the side measure here, FG, I have 4 units, but F prime, G prime is 3 units. So from the pre-image to the image, we had smaller image. The pre-image is bigger, the smaller image. So that is not a translation, because in translation we have to have exact same size of shapes and same orientation. So the orientation is the same, but this is again not a translation. So we say no. Does the image below represent a translation? No. Explain. Because after the transformation, the image F prime and H prime G prime became smaller. And that is a different transformation in math. That one will be called scaling or dilation. So making a figure bigger or smaller is not a translation. So here we have another question. Does the image below represent a translation? Explain. This is another no, because if I look at my triangle X, Y, Z, what happened here is when I translate, remember, I need to be moving the same number of units right, down, or down, right. And what happens if we move right and down, we don't have the same orientation. So in the translation is sliding the figure, same number of units, same direction, so sliding every point. Therefore, the figure will have the same orientation. This one is actually a flip, or I can flip it over the y-axis, then I can rotate it, then I can slide it down. So it's a series of transformations that we haven't learned some of them about yet. So if you think of a translation has to be always same size of the figure and same orientation. So here we clearly don't have the same orientation. There is other transformation involved. So this is not a translation, because after the transformation, the image x prime, y prime, z prime does not have the same orientation. So here we have a contradiction to our definition. Every point has to be moved same direction, same number of units. No flips, no turns.